Okay.
Carla, so that is everything from my end, and the floor is yours, please.
Okay. Hello, everybody, and welcome. This is FGDLA's Government Learning and Technology Symposium Series. I'm Carla Lane, FGDLA's Vice President for the Higher Education Sector, and the moderator for today's workshop, alongside Russ Colbert, who is FGDLA's VP of the Corporate Sector. FGDLA is a nonprofit professional association formed to promote the development and the application of distance learning in the federal government. We actively foster collaboration and understanding among those involved in leveraging technology and instructional media in support of the education and the training needs of the federal government. Our membership is derived primarily from individuals employed by the agencies from the federal government. We invite you to join with us in this exciting field. You'll find membership forms at usdla.us. Excuse me, fgdla.us. Boy, talk about a throwback to USDLA. So for upcoming events, on August 14th, Tara Shandell of DLI will present on the DoD and responsible use of AI. Ellen Finkelstein will present on using Copilot with PowerPoint. The date for that is September 18th. Dr. Jenny Varicchio will present a 2-hour workshop on gamified learning design using generative AI. This is part 2 in the series, and the session will carry FGDLA certification. On November 13th, DAU's Brenda say her name correctly, Sedlacek, will identify instructional strategies for great webinars for producers and program directors. The FGDLA Awards will be presented on December 4th, so watch for the entry form for that. It will be out soon. We hope you'll join us for these very special online events. We are so proud that Zoom and Moodle have become such valued sponsors for FGDLA. I'm going to go to the next slide, Anders. So next one, there you go.
Right.
They have been instrumental in helping us present the webinars. We recently announced that COSO Cloud has become a new sponsor for FGDLA. COSO Cloud is a Class Technologies company and a leading provider of secure, customized e-learning solutions for the government enterprise sectors. Joining forces with COSO Cloud will enable FGDLA to continue to offer comprehensive and future-focused learning solutions to meet the training needs of the federal government. We are so honored to have these wonderful sponsors that are giants in the industry. We thank you. You are the best. The topic of today's webinar is, I want to move to the next slide, accelerating Navy learning with mobile VR and handheld gaming PCs for onboard ships. Talking you through this is Dr. Anders Gronstedt, who worked with the Navy to develop this VR training for Navy submariners. He is the president of the Gronstedt Group and a pioneer in extended reality training simulations, having worked with some of the world's largest employers. And he'll be showing you some of the things that he's done for those, as well as working with the Navy. Serving as panelists today are Dr. Erica Jacobs and Russ Colbert. Erica is the Deputy Director and the Capability Support Branch Head in the Ed Tech Department at Marine Corps University and is president of FGDLA. Russ is the FGDLA Corporate Sector Vice President and was a Surface Warfare Officer in the U.S. Navy. Prior to an exceptional career in the telecommunications industry with Zoom, Polycom, VTEL, and other prominent corporations. And now, Anders, the floor is yours.
Well, thank you so much, Dr. Lane. Really excited to be here. So I'm joining you from Denver, Colorado. As you can tell from my accent, I'm born and raised here, but I've been working on my Swedish accent for the last several years here, so I thought I'll try that out. So I'm president of the Gronstedt Group. We've been in business for 27 years. I've been in the US for most of my adult life, and we custom develop virtual reality training programs, mostly for enterprise clients. But we had this really interesting project that I'm gonna share with you here, working with the Navy in the last year. So during this hour here, I'd like to take you on a journey through some best practices in VR from the enterprise side and show lots of examples, because VR is very visual, and it's of course very difficult to demo over a Zoom session like this. So we'll do our best here with videos, and I like this for this to be conversational. So Russ and Dr. Lane and Jacobs will be monitoring chat. So please feel free to ask questions, make comments along the way here. And actually, before we get started, I'd love to ask you all about your experience level with virtual reality. If you wouldn't mind just putting in text chat there, if you have tried modern VR, such as the Quest that you can buy as in the retail stores. Anything beyond, you know, the early days of Google Cardboard or something. If you've been in a VR headset, just had that experience, that would be helpful to know.
Lots of yeses coming in.
Okay, great. Yeah.
Hey, Anders,
yeah.
Anders, before we get started,
Yeah,
the
absolutely.
last name of your coworker, Brian
Foss.
Foss. Okay.
Yeah, right.
Thank you.
Yes, he will. Yeah, my colleague Brian will be here to help answer technical questions as well.
Okay.
So great. So most of you have experience with VR. That's really helpful. So the way we position virtual reality for training is that it accelerates proficiency through hands-on practice with personalized feedback and unlimited do-overs. It's do, fail, reflex, and succeed in a highly realistic environment. So this video is an example of work we've done for a trade union, actually, the finishing trades. They're using this to recruit painters and drywallers, and in this case glazers, who put in load-bearing windows on skyscrapers. And using VR for recruitment is just a great application, and it just blows my mind that the government is not doing more of this. So they bring the headset, you know, we're talking about the $500 Quest 3 headset. They bring it in a backpack to recruitment fairs, and people get to experience what it's like to be on a construction site. Imagine doing this for government work, for instance, being on a Navy ship, for instance. And they use this to diversify recruitment also. So young women in high school who might never imagine themselves out on a construction site like this can put on the headset and magically find themselves there. And they can have the sensation of looking down from a skyscraper. And some people are not really cut out for that type of work. Other people are thrill seekers. And what better way to experience that than in a safe environment where nothing is going to happen to you. And so a few things to point out here. This is, of course, you have to imagine here, you're in the VR headset, you're looking around, you have this absolute sense of presence, of being there. You're collaborating with, in this case, a non-player character. The full-bodied character there is a AI character. So you can play this as a self-paced program. There's step-by-step instructions. I'm going to show some more examples of that. Video instructions, voiceover instructions. And the people you see here who are floating heads and hands, they are real people who are in there. And if you're new to multiplayer VR, it looks a little funny perhaps with the floating heads and hands. The reason for that, of course, is that the only thing tracked in space is the head position and hand position. And while there's a lot of work going on and having full-bodied avatars, for most of the technical training that we're doing here, the floating heads and hands actually work fine. And the brain does amazing things. It fills in all the gaps. And you have the sensation of presence, of being together with other people in that environment. You can talk to them, and as you can see here, you can collaborate with other people, working with them on tasks with real people as well as computer generated people in this environment. Any comments or questions on what you're seeing right here? Or Russ and Erica?
I loved seeing the fact that the two people who have the devices can interact. I saw the little dance going on there, but just the fact that they could actually work together too.
Right, yeah. So to be clear, they can be, of course, physically co-located, but they can also be appearing from all over the world. But in the VR space, you have this absolute sense of social presence with each other. You feel like you're working together. It's really
How many people can you?
So yeah, great question. So these spaces usually have a cap of around 6-7 people, and that's also kind of a practical limit. If it's a hands-on program where you're working together, that's usually how many you want. But you can sort of expand it beyond that and have bigger groups. It also depends on like how interactive you want things to be. If you want it truly interactive, where you're grabbing things, interacting with things, collaborating on tasks, then that limits more how many people you can have in the same space. So so that's a little bit about the what VR is and what the value prop for learning and development is. I thought I'll mention this in context of augmented reality, because they do get lumped together all the time, and you guys probably all know the difference, but just to state perhaps the obvious here, virtual reality is kind of like a digital blindfold. It's like lights out, you are transported to that construction site, or you're going to see example here later of being on a submarine machinery room. Whereas augmented reality, you're seeing the physical world around you, and it brings you in virtual information on top of that. And the implication and the application for learning and development is typically that VR is for training and AR is performance support. So a metaphor that I think everyone can relate to is pilot training. VR is the flight simulator that you go in to learn how to fly a plane, and AR is the heads-up display that you see in the cockpit when you're actually flying the plane. And I want to bring this up also because I get into a lot of, I think, silly arguments when we present where people go, oh, well, I like AR better than VR. It's so much more powerful. Well, they're two different things. And it's a little bit like saying that you like heads-up displays better than you like flight simulators. They serve different purposes. And they obviously, the technologies are closely related. And in fact, they are blending more and more. So it's probably making less and less sense to even make the distinction because now we have this new generation of headsets coming to the market in just the last year with which are VR headsets with pass-through video capabilities. So on the Quest headset here, you have 6 external facing cameras. Apple just launched the one with 12 external cameras. So rather than a see-through lens like the HoloLens and the Magic Leap, you have a live video feed that's close to, in the case of the Apple Vision Pro, almost entirely picture perfect. With the Quest, it's a little grainy, but it's like 95% real. So that's really starts blurring the lines, and there's a lot of confusion here about the term. So now, of course, the tech giants are trying to brand this. So Apple calls it spatial computing. Meta, Facebook calls it mixed reality, but it's really the same idea. It's about using the path in this generation headsets, using the pass-through video to integrate the real world around you with virtual objects. Does this, Erica and Russ and Carla, are you?
Very
I know
exciting.
there are different ways to.
Very exciting and very informative.
Right, thank you. Yeah. So let me take you through a few quick enterprise examples of VR, and then we move into the Navy case. I think it's important for context here. And I also want to highlight that this VR is a mature technology. It's been here now. The headsets have been around. The mobile headsets have been around now for 5 some years. And there are real robust use cases in the enterprise world, probably more so perhaps than in the government space from what I've seen. And I think pharma is one of the leaders in this. And we've been working in a particular space of pharma, which is really interesting. It's in cell therapy, where for certain forms of cancer, you draw the blood of the patient and you genetically modify it in a lab and infuse it back into the patient. So the healing essentially happens in a lab. And this is revolutionizing medicine. More and more cancer forms are going to be treated this way. It's already solved childhood blood cancer, and it's predicted to be able to solve things like Parkinson and Alzheimer in the future as well. And the challenge with this is the pharma companies have to hire thousands of lab technicians to do these very delicate tasks, and they're hiring pretty much from the street people who might have a McDonald's or other background, no life science background, have to learn how to do work with actual patient blood. So you're in a clean room and it's hands-on procedural training, and that's really the low-hanging fruit for VR, is where the stakes are high and you need to do it's really important that you do things exactly the right way every time. And this video is shot from the perspective of the headset. You see your own hands. So as you do, in this case, changing a cartridge and welding a plastic tube in a plastic tube welder, you're using your hands, and there you see the instructions. So the step-by-step instructions showing you exactly what to do and using your hands. And as you can see, you can do some fairly detailed tasks even while holding on to the hand controllers. And you see your own hands, which makes you, after a few minutes, you forget that you have the hand controllers and you feel that those are your real hands. And in fact, the tubes, we worked a lot on making these tubes look real. It actually taken us several years. One of those details you don't think of. But when you stretch the tube in VR, you actually start imagining that there's resistance in your hands. The hands feel what the eye sees.
The qualities in these? Are there haptic qualities?
So great question. So the hand controller has this rumble vibration. That's really the only haptic feedback we have, but that goes a long way. So when you every time you touch something, you typically so you can program when you want that rumble, and so just enough physical input along with the sound, of course, which is directional. You hear it from where it comes, and the sight. And another example, my next example here, when you put your hands in the biosafety cabinet, what was highlighted here is that the air is being pushed from top to bottom, and so we have a slight vibration. You can do more vibration or less, slight vibration every time you have your hand inside there, and that also just enough stimuli that it transports you. You start imagining that you're there. And I'll play this video again. What I want to highlight here is that with VR, you can go beyond reality. You can extend reality. In this case, visualize the invisible, visualize the airflow. It's really important in this task to understand that the air is being pushed from top to bottom, and you're not supposed to cross your hands. And when you open a bottle, it will be contaminated if you don't. You have to angle it in certain directions. So as you're moving your hands and moving the ball there, the air is dynamically moves around your hands, and you can see that contamination happening in real time. And being able to visualize the invisible we'll show you more examples of that, is one of the superpowers of VR. So certainly we always get into arguments. Are there things you couldn't do in VR? And actually, Brian, who's here, he likes to use the example. You can't tie your shoelaces in VR. We have another example here of gloving and gowning, and being able to put on a rubbery glove on your hand and make that completely realistic. It's just not. It might be possible, but you need a huge budget to do that probably. So there are limitations. In this case, you also can't really see down on your body. So we created this virtual mirror. So as you're moving in VR, you see your mirror image here, and we're learning to gown, and really mostly about just putting things on in the right order. You're not really going into detail on how to like strap it around your ear or pull on the gloves. So there are limitations, but there are also things like visualizing things that you can that you couldn't do in real life. So it's all about using VR for what it's best at. And for other things, you just have to use other means. It's not an all-purpose thing.
Like the crawl, walk, run. This is the crawl phase where you're just learning those steps, like what's supposed to happen in the order.
Right. Yep. And of course, for these skills, there is an element where you go into physical lab and do this, but you can prepare people so that you can really minimize the time that they spend in the physical lab, which is a bottleneck for them. This is what a class looks like in the lab with multiplayer. So again, you see
step we're going to be removing.
You see the floating heads and hands, and it's actually practical if you want to everyone gather around the biosafety cabinet. Everyone has the best seats in the room and can see what's going on. And you can see more examples here of collaboration, of handing items from one person to another. A question you might have is, what does a VR classroom look like? Of course, VR, you can do it anywhere. You can be in a living room or a conference room. But if you're going to train thousands of people in a single location, which these pharma companies are doing. This is one of our pharma clients. There's no desks, chairs, just one screen at the end of the room, and they just laid out anti-fatigue mats and have headsets that you check out. So most of our clients have a shared headset model where you just come in and you use the headset. So it's the same headset can be used for hundreds of people. And the anti-fatigue mats are both practical because they're convenient, of course, because you usually stand up in VR and it's nice to stand on it for if you're going to be there for a few hours. But it also is another indication if you walk too far, you have the visual boundaries in VR, but you can feel with your feet if you walk outside of your area, and of course it's a safety thing then that avoids collision with other people. So quick other example, more on the marketing side. This is for Daikin, an HVAC maker. They're using this for big events. And this goes to show again how VR can be used to visualize the invisible, have X-ray vision. So they wanted to show the competitive advantages of their HVAC makers. So you find yourself on a rooftop and you can have that sensation of looking down. And to see the inner workings even better here, our team came up with a solution of you clicking on different units, they fly out, and you can see how they work. They're all animated, and we even use for the airflow here, we use colors to indicate how the air is coming in, and you have text pop-ups, but more importantly, it's in multiplayer. You can have a subject matter expert also walk you through. Here's an example of visualizing how the hot air is being pushed in and chilled, and the cold air is pushed into the building there. And so you can have an expert going through this, and the feedback we're getting is that having a demonstration like this in VR with an expert literally poking your head inside of the equipment, showing you how the fluids and gases are going through, in this case a chiller down in the basement here of. These are the type of chillers that will keep a hospital or skyscraper cold. But you can explain these fairly complex mechanics in just minutes, whereas with videos and PowerPoints, it can take an hour to do the same. Another point I want to make is they also have a traveling exhibit in a truck, and so there wasn't the floor space to do VR. And I'm gonna get into that shortly here with on submarines have actually similar constraints of floor space, because you do need at least like a 12 by 12 feet area to do VR effectively, and if it's room scale. So they asked us, can you do it on a touchscreen? And of course, these programs were all developed in game engines, so you just have to change the interface a bit, and you can still do multiplayer, so someone in a headset can appear on the touch screen here. And of course, you lose out on the sense of presence when you're just interacting with the touch screen. So it's you definitely trade off, but you have the accessibility in a tight space. So yeah, those are my enterprise examples. From here, we're going to go into the Navy case, but I'll stop here and ask if we have any comments or questions.
I don't see any questions in the chat, so.
All right. Well, let's get into the Navy case then. So we were brought in last year.
And let's see, the Navy is the only branch of service. Is that correct? That's the only branch, right? Say yes. Say yes.
Yes. Yes.
Okay.
Which includes the Marine Corps, right?
Yes, it does. Yes. Yes. I knew it. I knew it. We get some chat.
Yeah.
We have two Navy.
Yeah.
Thank you, thank you, everyone.
Yeah, I'm biased too. In addition to working with them, I was just telling Russ I served in the Swedish Navy as for my mandatory military service. So so the Navy had an interesting challenge. They have a program that they call MERTS, which is a large touchscreen training program. So they bring students in to do training where each student is in front of a screen like this, and you have an instructor in the room driving the training experiences. And the challenges with this was one, a matter of just cost and logistics of getting everyone into the classroom. There are studies suggesting that the training pipeline congestion in the Navy costs the Navy 400 million a year. So students have to wait for weeks just to get into a classroom, which is costly. And then, of course, we have the knowledge decay, the forgetting curve. You all know about the studies that the minute we walk out of the classroom, we start forgetting it. And within minutes, we've forgotten half of it. Within hours, we've forgotten another half of it. And within it's exponential loss, of course, if you don't repeat the knowledge. So could you do this in VR on a ship? Or in this case, on a submarine? So that was our pitch, and we talked to them about it. And we, under a CRADA, which is a research project so it's a self-funded from our side project, we took a program, a module, technical training from the submarine diesel engine room, a startup procedure of the diesel engine. And we took the Unity file that they've been using on this large touchscreen, converted it into virtual reality, also converted it into a self-paced format, because the program they had was more of a sandbox format where a live instructor in the room where I was driving the training events. So the vision here is that you get a much more immersive hands-on learning experience, and one that's self-paced and mobile, so you can actually do it out on the ships and submarines and get that spaced repetition to avoid the learning decay. And perhaps also before you get into the classroom, you can do it. And perhaps even in the classroom, perhaps you can do away with the classroom altogether. The opportunities here are pretty interesting when you start thinking about it. So I'm going to share with you what the learning experience looks like. It's for this part, because it was self-funded, a single player experience. And an interesting constraint we had to work with here is that this machine room is so packed that there weren't any natural space to put the instructional modules in. So our team came up with this model of having these sort of digital iPads of sorts that you always have at your waist. You can put mid-air. That's part of the magic and superpowers in VR. You can just put instructions anywhere you want, where it's convenient. And the instructions tell you step by step what to do. We also have arrows in the deck that leads you to the next step. And so you're walking around here, turning on the engine. So you're turning valves, and you have to imagine here, this is what you see in the headset. You're physically walking around. If your space is too small, of course, there's the thumb controller on the hand. The thumbstick on the hand controller you use to move around. And to do things like turning a wrench, rather than on the touchscreen, you had to use like a 4-finger touch to do it. Here, you're just grabbing the wrench, you're leaning in and you're using your hand, you're tightening it. And you saw that visual indicator of how tight it is. And the interesting thing is, as you have the hand controller, which kind of feels like a wrench and actually has the same weight, pretty much of a weight, you start imagining that you actually are there. And you start even imagining that there's resistance when you see that visual indicator. Just enough stimuli again to really feel like you're actually doing the task. And you have the step-by-step guide there on the screen. So it shows you a video. If you get it right, the next video is queued up, the next instruction step is queued up. And if you make mistakes, there's immediate personalized feedback, and you get to do it again. You get more and more feedback if you can't get it right. And here you're in a control room, and so you're opening the doors, you're pulling the levers. And interestingly, there's one step here where in the final step where you turn it on, where you have to push a button in one direction, pull the lever with the other hand. And those are the kind of things that on a touch screen you had to do like a split screen, and was really hard to get across. But in VR, it's just like reality itself. You're using your hands as you're doing it. It was also interesting working with the team that had developed it for the touchscreen. There were some people had never been in a submarine machinery room themselves and only seen it on a touchscreen and didn't quite see the perspective and distance to things. So there were some things that were really high up, and that if you're shorter in stature, it was really hard to reach to. And just like in real life, it's in VR, it was hard to reach, and we had to ask the subject matter expert, and they're like, oh yeah, so for that valve you have to kind of lean out and you have to hold on to the railing and to get it. And that's a kind of scale and perspective and realism that you never get on the touch screen, and that the people who had been working on this program for years didn't quite have a good sense of. But in VR, there it was like, wow, it's like reality. And the feedback we're getting from people who have been in the machinery room are like that this is absolutely feels like the real thing.
So Andrew, so what you're saying is that this is creating like a muscle memory that then transfers to reality? Interesting.
Yeah, that's the whole idea. Learning by doing and developing that muscle memory to do it exactly like you would in real life, and failing safely, being able to try it over and until you get it right.
So are they able to keep coming back and doing it? I'm sorry. Can they keep coming back and
right? So that's the vision.
They can
this is all
it.
right. This is all a demonstration project, but that's a vision of having it on the submarines in this case and being able to do it over and over. And specifically, this is something they would only on a 6-month tour. They might only do it 10 or so times. So it might be weeks between. So like right before you know you're going to do it next morning, you do a refresher on it. So the just-in-time learning aspect is, of course, really critical.
I guess around nuclear submarines, that's a good idea, huh?
Yep.
So my question was going to be, when you said that they do a step wrong, it stops and gives them feedback. And actually I'm looking, and I think there may be a similar question in the chat. What kind of feedback do you give them? And then you said that if they do it correctly, it moves them on to the next step automatically.
Right. Yeah,
that's cool.
So so it's the feedback is all customized to the particular step. So it will tell you exactly what to do, and if you still within a few tries can't make it, it will give you more hints as to what you're supposed to do. So typically the way we do this is the first time around it's this step-by-step guide, and then after you've gone through the whole program, we take off the training wheels, and you might just have a checklist of things to do like you would in real life, and you do the whole thing. And that might be, if you get stuck on something, we have like a hint system, but so rather than telling you exactly what to do, we just give hints to it, and then you get feedback at the end. So that approach of sort of starting with a learning approach step by step, and then a practice approach where you go through the whole sequence can be effective. And you can do this different ways. Of course, you can show the consequences of making mistakes. Mostly because of budget reasons, you can't go on if you don't make it the right way. But with the right budget, of course, you can even have things explode and stuff if you make it wrong.
That's pretty cool.
So yeah, thanks. So we took this out to a group of testers, and this was a real interesting experience. So we went to Bangor outside of Seattle and tested it with a group of it was 23 responses, but it was 30 plus some sailors who went through the VR experience and who had done the touchscreen training program in the past, so they had that as a reference. And so to be clear, this is all self-paced. All we have to do is put it on their heads, and these young people are, of course, savvy with VR and just whip through it in maybe 10 minutes. And by the way, everything is self-paced. Even we have a tutorial at the beginning that teaches you how to use the buttons and everything on the hand controllers. So there's no live instructor needed. And then we asked them about the experience and comparing it to the touchscreen experience. And so rate your overall experience of the VR approach to learning. 3/4 thought it was excellent. 1/4 thought it was good. No one was neutral or thought it was bad. How would you compare the experience in VR compared to the touchscreen experience? One person was neutral on that. 2/3 thought VR was much better, 1/3 thought it was better. How easy was it to use? Everyone thought it was very easy to use the system. Would you be interested in using VR simulations for learning and practicing other hands-on skill? Everyone was interested in that, and like more than 3/4 were very interested. And the qualitative feedback was equally glowing. They were saying things like easier to operate compared to the touchscreen monitor there, easy to walk around, realistic tool movements. It was the most fun user test we've ever done. They were just so elated. It was just so fun to see their expressions in their faces. They were just glowing with excitement about doing training this way. So it's definitely like a fan favorite of the sailors. And in honesty, obviously this is level 1 Kirkpatrick. I recognize that. We don't have the hard data yet of how to the actual performance impact. We're hoping to do that research, but I mean, this is just off the chart. We haven't had these kind of numbers on anything.
Yeah, well, it's not like you asked them if they like lunch, you know, I mean,
yes.
this is a little bit higher level, I think,
Yeah.
on Kirkpatrick, maybe a 2 coming on to a 3, particularly because you've got a bunch of techies who are using a technical aspect.
Right.
And I mean, if I got responses like this on anything, I mean, you'd be through the roof, you know.
Yeah,
over the roof
right.
with
Yeah.
These kinds of answers.
Yeah,
and
yeah.
Wow.
Oh, and by the way, these sailors had also done the task in real life on a submarine, and they were all saying, wow, this is exactly the way it looks like in real life. So yeah.
That's great.
Yeah.
Stellar.
So interesting twist, though. As you can imagine, getting headsets onto ships and submarines has a few challenges. Number one is, of course, cybersecurity. So getting through the ATO process. So the headset with 6 cameras and Bluetooth and microphones is a little sensitive, and there are also concerns about it interfering with the electronics on board the ship. In addition to it being able to ingest data from the ship. So the team we're working with is trying to get this approved, working with the hardware makers to get it approved. So that was one challenge. The other one is, of course, comfort and space requirements. So on the submarine, it's mostly not so much comfort because the submarine is most of the time stable, but space requirement, of course. The only space large enough to do VR was, according to our subject matter expert, is in the torpedo room when it's not used for other things, because you need a certain amount of space for it. And of course, on surface ships, you usually have more physical space, but then you have the whole issue of a moving ship. And VR has its own issues with seasickness, actually a lot less than people think, but it's there. And according from what we've seen, that no one has really done a study of the impact of doing VR on a moving ship. So that's part of the research we have to do. So the question was, of course, these were interesting challenges, and we are pushing through and really think that it's going to work on ships. But we realized that we needed a complement to the VR experience. So what we proposed to the Navy team was the handheld gaming PCs that were launched last year. And if you haven't seen them, you're forgiven because they've only been out for a year, but I'm sure you've seen the Nintendo Switch. You probably have kids and other people around you who are playing that. This is a similar form factor. It's a mobile gaming console with a nice screen in the middle that has a touch screen also, and they have the game controllers to the side. Unlike the Switch, they're permanently attached to each other. But this obviously opens up opportunities on a ship. First of all, probably easier ATO cyber requirements because it doesn't have all the cameras and all. And they already have, this is a PC, it's a Windows machine, which they already have approval for. Not that it's going to be automatic, but probably an easier ATO process. And also, of course, comfort. Our pitch chairs, you can lay down in your bunk, you can sit in the mess hall and play it. It's just the accessibility is unrivaled here. And it's a very compelling experience. You are certainly trading that hands-on immersion and developing the muscle memory, but you're trading it for increased accessibility. And in our experience now, in my own just demoing this, doing it first in VR, I feel like I've been in that machinery room, and then doing it over and over on the handheld, it really drills it into your mind where it really becomes second nature. And I'm pretty sure I could go into that machinery room now and start up the engine.
Yeah,
So
Andres,
yeah.
there's 3 questions in the chat, but I'm
Mhm.
looking at the time. Would you rather
Yeah.
go ahead, finish the presentation and then answer the
Yeah,
question?
actually, I'm pretty much done there. So go ahead and actually this, yeah, the summary is that we are now actually have a paid project that we're going to start in the next few weeks to develop it for the handheld. The Navy sees this as the best way to get onto the ships quicker than VR. So in parallel, they try to work through the cyber approval with VR. So we are starting to develop a full module now for the handheld. And so the theory here is that this combo of mobile VR and handheld on ships is really going to address the cost issue and the issue of combating the forgetting curve with one and done classroom events by having space reinforcement at the point of need out on the ships. And so, yeah, I'd love to open it up here for conversation.
Okay, Erica,
Anders, real quick, I'm here.
Go ahead. Oh,
sorry,
finish.
Anders. I'm here. I'm Brian Foss. I work for the Gronstedt
Right,
group.
sorry. So I got my colleague here, so as our development lead. So for any more technical questions, I'm happy to have him answer them as well.
Okay, Erica, there's a question from Carrie Taub. You want to go through that one?
Yeah. So Carrie is asking, what would be the best to merge real life tasks with software simulations? Because it seems like a lot of times, we to learn those physical tasks. So what would be the best way to merge those real life? And then she gives the example of customer walks in and asking to check into their luxury hotel. Scene pans out and brings the computer screen to the front desk and the clerk for the check-in process. Yeah, so right, I guess. So,
yeah, go ahead.
Oh, go ahead.
So it's a question about learning to interact with other people in VR. It sounds like that, at least part of the question, which, yeah, you can do in a few different ways. You can have another live person appear as an avatar and have a conversation to a real person. Of course, with the recent advancements of Gen AI, you can have an AI powered computer generated non-player character that you can interact with in a dialogue setting. And yeah, you can bring in screens. You saw in that Daikin example, a touch screen where you interact. So you can have a computer screen that you're interacting with as well in the VR environment. So yeah, having things like people, screens, the way you would in real life can all be simulated in VR. What we would advise though is that if it's just an IT training, it's probably better to do it on a computer. Say the thing with VR, it requires a separate piece of hardware. It's there's certainly some inconveniences associated with it. It should only be used when you absolutely have to use VR. So if it's just an IT training, probably better to do it on a computer. And sure, frankly, even if it's like having conversation with one person back and forth, might not be enough benefits to do it in VR. I know there's a lot of talk about the VR being the ultimate empathy machine and making it more real. There's certainly a case for that, but you can also argue that maybe that dialogue can be done better either in a classroom with a live person or on a computer screen. So you always have to weigh that. Is it something you absolutely have to do in VR? But if it's something like bringing everything together, the computer screen, the live person, physically walking around and maybe guiding them, then VR can be a really compelling solution.
Yeah, and I guess I kind of have a second thought on that one with, do you ever build out branching scenarios?
Right. So that's the kind of classical way of doing it for dialogue, for instance, but it is a little clunky in VR. You know, clicking on multiple choice option, reading is, you have to really strain your eyes to read. You don't want to have too much text. So yeah, that's where the promise of generative AI comes in. Yeah.
Thanks.
Next question is, what is the timeline for developing the submarine module?
Yeah, I'll turn that over to our lead developer here. Brian, do you want to take that?
Sure. So we had the benefit of starting with the existing MERTS 3D program. So we had to take the assets that they used to build their program, optimize them for VR, add in all of the virtual reality interactions, interactivity, and the self-paced learning steps, the actual learning design that we implement. And that took us 3 months. That time would be, longer if we didn't already have a digital version of the submarine to start with. But it's also not extreme.
And so, sort of a general point of the cost and time involved in this, it's developing things in VR as opposed to the more traditional e-learning or video-based approach. It takes more time and cost upfront to model the environments, the equipment, but once you have all that modeled out, developing additional modules can be done very cost effectively. But that's always a challenge with clients to take that long-term perspective of investing in modeling out your environments and products and whatnot, and being able to discount that over the course of several years. It's a very future-proof investment. We have programs we developed for the first Quest headset that's now like 6 years old. So while the headsets come and go, probably with 1 or 2 year cycles, the programs that you develop will have pretty good longevity. So it's definitely worth making that investment.
Hey, Russ, you want to do the next question?
Carla Hannah says a lot shorter in development than she thought.
Yeah.
So kind of surprising shortness and transitioning with the virtual reality.
So to be clear,
learning.
If we had to start from scratch, it would be perhaps more of a 6 to 9 months time schedule. But we are understanding now from our we're used to working in the enterprise side where like 9 months is a real long time. We're finding now in DoD that that's you have much longer time scale typically for developing things. So our client was really surprised that we were able to develop this in just a matter of months.
Seems like you would also have to, in choosing what you would commit to this, how long will it be used? How many people will be using it?
Yeah.
I mean, it's not a cheap process to put together. And if there is a long-term development, you don't want something where it's just 10 people use it for 1 week and it's over.
Right. Yeah.
It doesn't make any sense at all.
The other thing about this is it's very flexible, unlike video, for instance, where you, even if you want to change the color of the shirt of someone's wearing, you have to go out and reshoot it. Of course, this is all made digitally, so making changes on the fly, and if you have updated equipment and procedures, it can be done relatively quickly.
Okay, next question was when the software is on the headset, it does not need to be online for operation. That's a question.
Yes, I'll turn over to Brian, because that was really critical, obviously being on ships, on a submarine in particular, where you're completely off the grid. Do you want to address that, Brian?
Right. So the module that we've built so far is a single player experience that can run completely offline. However, we are trying to get to a point where we can do this as a multiplayer experience. So you could have multiple headsets connected online from any location in the world. That really enhances the learning, especially if you have team exercises or something like that. But we understand that there are security concerns and all of that, so we tried to accommodate everything. The current module runs offline once it's loaded on the headset.
So the idea is that once the submarine is surfacing or maybe in harbor, you can connect it to, they have a learning management system, Moodle-based system that you can connect it to.
Okay. All right, Erica, you want to do the next question from Keisha?
Yeah, sorry, my internet dropped for a second, so I'm just getting back in on things. So,
do you see it, Keisha Martin?
Yep, I do. Okay. All right. Have you developed any training using hand tracking?
I can take that one.
Yes. Yeah.
So the answer to that is no, but it's not for a lack of effort. We've definitely experimented with hand tracking. We've looked at what's available to us. The big problem is that
And to be clear, what we're talking about, this is where instead of the hand controller, you're just wiggling hand, doing it in midair. Yeah, right.
The big problem with that is typically hand tracking is less reliable input than the controllers. So if I'm using a controller, a button is either on or off. So you're either grabbing an object or not. With the hand controller, you need to use image recognition to find whether or not somebody is picking something up. And what this often leads to is reaching out to grab something and you kind of just pass right through it. You don't pick it up on the first try. And when it comes to training, when you have little bugs like that, the cumulative effect of those bugs can completely destroy any learning that you're going through. So that's the reason. We hope that it gets better in the future. We keep looking at it. We may implement it at some point, but right now it is much more reliable to use controllers, and we found that it's very intuitive for anybody, especially anybody under the age of 30.
We have a tutorial that just takes a few minutes on where to press, and after a while you forget that you have them. The other issue that I mentioned is you have the rumble, the vibration, some haptic feedback, which is actually surprisingly effective, and also there are things like moving around in a large space using the thumbstick. Now there are ways to do that with hand tracking, pointing at the floor and stuff, but the thumbstick is just a very natural way of moving around. So it's kind of established itself. And I guess the proof of the pudding, which Brian likes to point out, is there aren't a lot of entertainment games out there that uses hand tracking, which suggests that the fact that almost 100% of all games are using their hand controllers suggests that that's still the best way to interact with the 3D world for right now, where the tech is.
Yeah, and if you were going to do hand tracking, would it require a different device or something on each digit to
No,
manage that? Or
that actually works just fine on the Meta Quest 3.
Okay.
There are other headsets that have hand tracking solutions. I do think Meta's might be the best on the market, although
of course
I think
the Apple Vision Pro
is giving it a run for its money.
Yeah. They use only hand tracking right now.
Yeah.
Okay.
Yeah. And most of the AR headsets only use hand tracking. So the Microsoft HoloLens and the Magic Leap headset. But yeah, we've messed with it. We hope it gets better. But we currently still recommend controllers.
Awesome. Thank you.
Mm-hmm.
Hey, Russ, Sandy Wagner's got a question. You want to ask her question?
Well, our dear Sandy asked, Anders, do you have any examples of incorporation for language acquisition?
Yeah, great question. So the examples you saw here are obviously very visual. The only language, the only words really are the text instructions on that screen, and sometimes we use voiceover, and that's very easy to replace with other languages, and of course any like signs and stuff in the environment. And then of course if it's a multiplayer, yeah, you schedule sessions with groups of students who all speak that language.
Yeah, Sandy is with the DLI, Defense Language Institute. So, it's a really pointed question on her part because of the types of training that they do. And,
oh, so she's interested in language training, perhaps then.
Yeah.
Right. Yeah. Obviously, this VR is learning a new language is all about immersing yourself into that language, and what better way to do that than finding yourself immersed in an environment where you speak in the language you're trying to learn.
So, for example, if you took what you did for the Navy and wanted to teach it in Spanish or French, would it be hard to adapt?
No, that would be super. I mean, the only thing we'll have to change are the text instructions on that little monitor with that you carry around.
Okay, interesting. All right, let's see. Erica, you want to?
There's one comment in Q&A from Paul.
Oh, okay. I don't have it open. Go ahead.
So Anders and Brian, the comment is the handheld gaming PC more flexible than VR if there are any changes or updates?
I would say the answer to that is essentially no. They're interestingly enough, they're both running pretty much the same project of software. So we develop in a model where we develop once and then kind of flip some toggle switches and deploy it out to different platforms. So it's literally the same program running on the handheld as it is on the VR headset. Now, if you wanted to separate that in some way so that the handheld had content that the headset doesn't, or vice versa, then you get a little bit more overhead because now you're sort of managing two projects that are very similar but have some differences. But for the most part, no, they're both very flexible.
Okay, thank you.
I can kind of address some of these questions with speed if you don't mind.
Go ahead.
So Anna asks, is there any way to program interactions? Oop, it just moved. Interactions with where different choices lead to different outcomes? And the answer to that is absolutely yes. We can develop sort of branch scenarios where if you do one thing, you're headed down a different path than you would be. And we can, of course, build in tracking to evaluate those things. And we can also immediately alert the user that they've made a wrong decision and now they need to apply different steps to get back.
Okay, we have Sandy online up now.
Thanks.
Sandy, you want to ask your questions?
Yeah, thanks, Carla. Yeah, Anders, great presentation, and
Thank
you
you.
know, I'm a believer in VR, and I know we've tried. I guess my question is, and Carla captured one really important aspect, which would be the ability you would require the communications, but we're looking at DLI because we're actually building high levels of proficiency for military linguists, ways to do role play. You know, we've experimented, but I thought, you know, you're so innovative. And is there ways where you would, excuse me, sorry, to actually promote, you know, build role play experiences? And, you know, we've always run into, are the responses accurate? You know, it's not quite as cut and dry as where you're actually on a ship or something like that. So that's what I was wondering. And, you know, because then we could, you know, really think about incorporating that more.
Right. Yeah.
It's
Yeah.
just
So
not that concrete. Yeah.
Right. No, that question comes up all the time. And obviously the benefit in VR is you can be in a bazaar on the street of Tehran and do that. So you have the whole context of it. People are wearing appropriate clothing and everything. So you really immerse yourself. And the way you do the role play, it really are two main options. One is to have another live person that you're role playing with. Then, of course, the question is, why wouldn't you just do it like here in a Zoom session or in a classroom? And it's that creating that context is probably the main reason why you would do that in VR. And the other option is to do either branch structured, like Erica suggested, or using generative AI and have a self-paced model where you're having a conversation.
Right. That's, because sometimes asynchronously in self-study, it becomes very valuable because then it's 24/7 access and, you know, and of course the generative AI, excuse me. But thank you. I appreciate the information.
Yeah.
Anders,
and that's,
I've got two questions that I want you to answer because we're running out of time. But the first one is, why aren't agencies using this more? And the second part of that is, what convinced the Navy to do this?
Great question. I actually have a slide of that. It's a bit of a soapbox, and I'm really frustrated because I feel like we're just dabbling. There are lots of little projects here and there, and this is a bit of a soapbox here, and it can be perhaps a good way to conclude this. Is I'm finding that in the military DoD space, there's this proclivity to that everything has to be 100% fidelity. So there's this race to capture that last 5% of realism with these omnidirectional treadmills, large gloves, cockpits, and there's certainly for some tasks there is a room and there's legitimate argument for that. But I think that a lot of times the DoD decision makers, they confuse the means with the goals. I've been to several meetings where DoD decision makers will say, our goal is realism. It has to be real. Well, your goal is never realism. Your goal is performance improvement. Whether realism is getting it 100% realistic and whether that's worth the cost and the practical issues involved with that is something you have to discuss. So while there's certainly room for having all these physical peripherals and having these high-end VR headsets that needs a gaming PC and external tracking cameras and not, there certainly are certain tasks that where that's called for, but for a lot of training needs, for instance, maintenance training like we're doing here, using these off-the-shelf low-cost devices, less than $1,000 that you can have, that you can forward deploy, that you can scale up, and where you're trading, perhaps you still have 95% of the realism, but what you're trading it for is 100 times the reps and sets at the moment of need is something that DoD needs to consider. So I think DoD needs to get more serious about actually doing this at scale. It's the time to just experiment and dabble is done. I think we need to actually do it seriously, and we need to look at where we absolutely need these more high-end simulations that are more modeled on the physical simulators that are run in a classroom with instructors, and where you can do it instead self-paced with low-cost devices that you can forward deploy.
Well, it seems like what I'm seeing and everything that you're doing. I mean, one of our main principles in education, how do we do things faster, quicker, better, deeper, be able to apply it, retrieve it, apply it, and so forth. And I think that what this does, what you've shown to us today, is a way of doing that. I mean, we know it's been around for a while, but to see an actual instructional designer discuss what was done and how to do it is really remarkable. So thank you so very much, Anders, for being here today. Russ and Erica, thank you. Brian, thank you for jumping in. Sandy Wagner is on our board, and Sandy, thank you for being here. So I just wanted to thank all of you and our sponsors for today, and we hope you'll join us for next month when we'll be back again. Okay, thank you all.
All right, thank you. This is great.
The webinar.
Thank you, everyone.
Thanks. Take care.